Have now OD228 in your possession.
There will be no 228 for us phase.
That's just fine because the difference is
1 minute to entry.
Within spitting distance.
Affirmative.
The vehicle will switch antenna shortly. We'll have a short dropout when that occurs in the tones, switching to a tilted antenna that will be used through entry.
As 30 seconds to entry.
As we come up on entry, we'll expect a 2 to 3 second outage in the X-band signal as we switch from the PLGA to the TLGA.
We're switching to the TLJ, signal's dropped, and it's...
We just saw the signal drop. That indicates we changed antennas.
We're seeing heartbeat tones again after the switch. Things are looking good. We got tones back again. Coming up on entry. Vehicle reports entry interface. At this time, it will begin pressurizing the propulsion system to increase the thrust of the system. We'll use that for all the maneuvering in the atmosphere we're about to do.
Back to heartbeat tones.
We are standing by for guided start and the start of guided entry.
Nav can see the entry in the atmosphere in the Doppler.
We are beginning to feel the atmosphere as we go in here. The vehicle has just reported via tones that it has started guided entry. At this time, the vehicle is beginning to steer its way to the target. It is starting its first bank reversal. First bank reversal complete. We have seen peak deceleration. We've passed through peak heating and peak deceleration. It is reporting that we are seeing Gs on the order of 11 to 12 Earth Gs.
Flight GDSA.
GDSA flight go.
We are processing data from Odyssey.
Bank reversal 2 is starting. We are now getting telemetry from Odyssey. All right. Bank reversal 2 complete.
Copy, bank reversal 2 complete.
Thanks.
Standby flight. We have a connection, but we actually do not have any data yet.
Copy. We can expect some intermittent contact at this time as the signal increases to respectable levels.
There we go. We are now seeing
and we have
Odyssey.
RTDPs.
Okay, copy.
And visualization is updated.
We have entered heading alignment.
There it goes!
At this time, Curiosity is no longer trying to control how far it's flying downrange and is just heading directly for the target.
End of range control, air used minus 1.2 kilometers.
Minus 1.2.
1.2.
The EL team is reporting that that things look pretty good at the end of range control. We have converged a lot of the error, and we should be heading toward the target.
Flight EDL, TDS warning is okay.
Copy.
Power on.
We are seeing a tone from
the 1 gigahertz?
indicating that we have seen heating on the heat shield through the MEBD instrument. Everything looks fine. This is as expected. During this heading alignment phase, we're flying almost horizontally like a plane. We're going about Mach 2.4 at an altitude of 17 kilometers or so. Vehicle's reporting heartbeat tones again, indicating that everything is fine during heading alignments. We are standing by for straighten up and fly right and parachute deploy. Vehicle's continuing to decelerate. We're down to about Mach 2. As a reminder, we should have parachute deploy around Mach 1.7. We're at 15 kilometers altitude.
We've begun entry balance mass jettison. The predicted mid downrange is 1.597 kilometers.
EDL ops, Odyssey Systems on EDL ops.
Parachute deploy.
Parachute.
Thrusters have been re-enabled. We will control our attitude on chute. We are decelerating.
Risk mode under
Our 10 kilometers
parachute
decelerating
are 20
and descending. We are at 150 meters per second.
Dynamics phase. Come back again with risk mode dynamics.
Risk mode is nominal.
We are at 9 kilometers and descending.
Active. Valid range.
Net filter converged with a velocity correction of 0.7 meters a second.
We've acquired the ground with the radar.
An altitude of 8 kilometers.
Feet has separated. We've found the ground.
Expand tones due to earth occultation as expected.
We're standing by to prime the Emily engines in preparation for powered flight. We're down to 90 meters per second at an altitude of 6.5 kilometers and descending.
Flight EDL, we got some Tweedo warnings. It is in battle short mode, so I should power through them.
Direct Earth communications at this time. We may have lost it already. We're down to 86 meters per second at an altitude of 4 kilometers and descending. We've lost tones from Earth at this time. This is expected. We're continuing on Odyssey telemetry.
Ground solution equals minus 10.8 meters, vertical velocity of minus 82.8
We are priming
meters per second.
start enabled, standing by for batch shell separation.
Signal to Odyssey is still strong.
We are in powered flight. We're at altitude of 1 kilometer descending, about 70 meters per second.
Signal to Odyssey remains
down to 50 meters per second, 500 meters in altitude. Standing by for sky crane.
Constant velocity accordion nominal. Altitude error 5.9 meters.
We found a nice flat place. We're coming in ready for sky crane. Down to 10 meters per second, 40 meters altitude. Sky crane has started. Descending at about 0.75 meters per second as expected. Expecting bridle cut shortly.
Signal to Odyssey remains strong.
Tango Delta nominal.
Yeah. EDL comm configured.
RIMU stable.
UHF telemetry.
RIMU stable.
UHF is good.
Touchdown confirmed. We're safe on Mars. Time to see where our curiosity will take us. At this time, flyaway should be complete. The set stage is at a safe distance.
We are continuing to receive telemetry from Curiosity. We're safe.
Getting data from the surface of Mars.
ASCAM sequence is kicked off, waiting for images. Heads up, folks!
EL ops, the signal to Odyssey remains strong.
Flight EDL images are starting to come down. We're beginning to get images. We got images coming down, folks. We do a comm configure stand by for images.
Seeing thumbnails coming down.
Odyssey data is still strong.
Odyssey data is very strong.
Odyssey is nice and high in the sky. At this time, we're standing by for images.
Thumbnails are complete.
Got thumbnails.
Poll image complete. Poll image complete.
It's the wheel! It's the wheel!
There we go. We can see a wheel image. We are wheels down on Mars.
Oh my God.
We'll do a proper hug on the other side.
Keep watching, guys. Keep watching the stream. There's more stuff. Any minute now. No. 2:56.
Okay. Okay. So here we are. We're going to start. Go ahead.
Okay.
So we have landed out at the time we thought we would, and we now have our first image.
We have our first image. This we've got is a 64 by 64 thumbnail. The front, a rear HazCam image. You can see the shadow there. I'm not sure exactly which our orientation is of the vehicle, but we're looking through it. I think in just a few minutes we might get even a larger 250 to 256 frame pixel image of that same end. So we're looking at the shadow. See, the horizon is actually in the distance. You can't really tell that. So we're looking actually at the shadow of this late afternoon sun.
So these are the rear HazCams.
These are the rear HazCams.
And it does have a dust cover on it.
It does have a dust cover, but it's the dust. The cover is the problem. It's the fact there's dust in the air because we have just blown dust all over the place with our descent engines.
Fantastic. So there could be more.
There could be more. If we wait, we might get. Oh yes, This is the high res. This is a 256 by 256 image. This is a higher resolution. You're seeing dust particles on the window. You can see the horizon there in the background, and there is the wheel of the rover safely on the surface of Mars. I can't believe it. This is unbelievable. We might get another one of these, and if we're lucky, before Odyssey goes away, we'll get 2 more of these same images going the other side of the vehicle, and also probably dusty. This is amazing.
So that is one of Curiosity's rover wheels
exactly.
On the surface of Mars.
Yes. This is another thumbnail image.
Is that a shadow?
That's the shadow
of the rover.
Curiosity rover on the surface of